name is Oliver, and what we are going to show you today is based on some applications. One of them you just saw, and the other Sven is going to present in a second.
Okay, so that is the ubiquitous to-do MVC app. Anybody seen before? I mean, the to-do app is a very common example in web applications.
Okay, and I asked Sven now to add some of the tasks we have for today. So that might be, welcome the audience. I think I just did that. Okay.
I think that will take up all the time because I'm such a bad typer.
Can you toggle it to done now because I did that? Okay, no. Okay, then it will be my duty today to inform you about GWT, what it is and what it is good for and stuff like that. And then Sven will have the even better task for today to explain you why it is even more cool to do all this stuff using Xtend. Okay, cool. And we want you to try that application, and maybe not right now because we want you to listen right now. But if you want, you can scan that barcode here or memorize that URL. And it's especially interesting to memorize that URL because we have a link to the GitHub repository where all the sources are in. So if you want to check out how we actually did it and if you cheated and stuff, do that. Okay, while you're doing that, let me tell you, if you want a web application like that, that means the web application is as responsive and as usable as a desktop application. If you want to have something like that in the web, there's some challenges you have to face or you have to deal with. And those challenges, exactly, thanks. Those challenges are, for one, there are different browsers. And if you want to target different browsers, then you have to take care of the differences inside those browsers, especially naming Microsoft products here, but not only. So there are really quite a lot of differences. And then there's a DOM. And if you know why, I mean, if you ever deal with a DOM, then you know why that might be a challenge. If you don't, then okay, good luck. Lucky you, better to say. Sorry. And then, huge disclaimer, so a challenge for me is JavaScript, and probably for some of you, because I think most of you are Java developers, who is not a Java developer? Okay, so I guessed right. So if you're a Java developer and you want to develop for the browser, then all by itself you have a problem because the language inside the browser is JavaScript. It's just like that. And even if you are a JavaScript developer, it's still a challenge if you're not the only Java developer in your team or your project gets large. It's a challenge. I don't say that's impossible, but it's a challenge. And also, probably, if it's a real-world application, you will have a backend. And that backend, I think, at least I would like to have a common language for backend and frontend. And the same philosophy, and then also a common tool set like Eclipse, for example. I would like that. And then also, I would like, if it's at all possible, to reuse some code. And then, at best, I would like to have the same developers doing backend and frontend. Okay. So this is the motivation. Why do we have a problem at all? And one possible solution, it's not the only, but it's one solution, is using GWT. Okay, and what does it do? It actually, at the bottom line, it does two things for you. One thing is it abstracts from differences between client and server programming. And it does that by allowing you to write all your code in Java, and the code that is supposed to run in the client, that is the browser, is compiled to JavaScript. And there's a compiler for that. GWT provides you with that. And you can also share code between client and server. That means you can pass around data structures from client to server and without you even noticing it. So GWT does that for you. I'm going to show you that in a second. And the other thing, as I said, there are two things. It tries to abstract from the differences between browsers. And it does it by spitting out a dedicated JavaScript version for each browser you want to target. So you can say, I want to target Internet Explorer 6 and Safari, and then it spits out 2 different versions of the JavaScript. Okay, and then eventually, because programming to the DOM is at least tedious, it provides you with a set of components, of widgets, that you can compose just like you would do maybe in a Swing program or in a SWT program. Okay. Now to the code. I'm a programmer, I'll show you code. And this one is about communication between client and server. This is, actually this is more or less exactly the code that we use for the application, for the to-do application. So we have a backend, and it is servlet. You can see that. GWT servers are just servlets, and we implement an interface, obviously having 2 methods, load and save. I think they are pretty obvious. You stick something in like an identifier and get back a list of to-dos, or you stick an identifier and a list of to-dos, and then it gets either saved or loaded. That's pretty straightforward. I think you know code like this, but now to the front end, that means the client, the browser, and you still see this is Java, but this stuff here is something special because we are using GWT. We're creating a service stub here that is asynchronous. And we can just use it, but we are not getting back the results from the server directly, but we are providing a callback, this one. And once the call is done, we get a callback to this method, and we are getting back the result from the server. This is just programming style you have to adopt when you develop for the web client. It doesn't matter if you're using GWT or straight JavaScript. Okay, but what you might even notice as well, this to-do here, going back one slide now, is the same to-do as this one. So we can share the data structure for to-do on the client and on the server, and without providing any boilerplate code for that. GWT does it for us. Okay, this was one thing. Client-server communication, now the other thing. And the other thing is programming UIs inside the browser without writing markup, but rather composing widgets. And there are actually 2 ways to do it. This is the first one, and this is the programmatic way. Who of you has done SWT programming? Okay, quite a bit. Swing? Still? Okay, you might be very familiar with that style of code, but you have something in addition, and this is like setting CSS styles, because we are programming for the web. Other than that, we are creating components, we are setting properties on them, and we are adding them together, and eventually we are adding listeners to react on user interaction. Okay, straightforward, but would you know, without detailed analyzation of the code, how this would look like actually when we display it? I know it because I did the analytics, but maybe you don't. And this is a drawback. And so because of that, there's a second approach to creating UIs in GWT, and it's this one, actually. This is real GWT code, so it's not stripped down or stuff. And what you do here is you create an HTML panel and provide a list, item, and then you compose some widgets inside. And this is, I think it's easily readable, at least. At a single glance, you see there's a composition between stuff, and you have properties that are set like this. But this is all static. So for the dynamic parts, it means like code, where you change something or an action gets executed, you still need Java code. Because of that, you need binding. And this may look like this. So you have a binding of a label. And going back one slide, this is this label. You match it by name. And then you can add something like a click handler, which says if the user double clicks on that label, this method gets called. Okay, so we have a tragedy right here, and Sven is going to resolve that tragedy. At least I put a large burden on Sven now, so the expectations should be high. What is that tragedy? Okay, you have two possibilities. Either you create your UI using XML, which is good because it's declarative and easily readable and stuff like that. And it's bad, at least for me, because it's XML. So well, it's a lot of typing still, and I think it's pretty tough to type XML. Okay, and you need Java code for the dynamic parts, and because of that, you need binding. And this means also code duplication. And on the other hand, you have something like imperative programming of the UI, and this is good because it's all in one place. You don't have two files and stuff like that, and it's actually easy to write. Maybe not that easy to read, but easy to write. But as I said, it's hard to read because it's imperative and you have to analyze it and stuff like that. And with that, having put up such a high aim, I'm going to pass it to Sven now. And
thank you.
Let him resolve it.
Okay, first, a very brief introduction to what Xtend is. It's an Eclipse project, open source. It's a programming language which aims to be a better Java rather than an alternative to Java or so. So we really wrote something which is statically typed, like in Java, using the same type system, so you won't experience any interoperability issues like you have with other JVM languages. It compiles to readable Java code, so you always know what it does and how the compiler behaves, and you can easily learn the language. It is much more concise, of course, because, I mean, Java is really verbose. That's the problem we want to solve. The ecosystem and all the community and the open source project, that's great, but the syntax is really verbose and not nice to read. And it has some powerful possibilities to build very, very cool APIs and abstractions. You will see them in a minute. So first we had this application written in Java, and then we rewrote it in Xtend, and this is the unfair comparison, 611 against 355 lines of code. Actually, I think none of these two solutions were just trimmed down to minimal lines of code, because that doesn't make much sense. You want to have very readable code which is easy to maintain. So let's see how the Java code looks like. That's a very typical thing. You will see this kind of code in almost any Java usage of any Java UI framework, like in SUBT and Swing as well, or Android. You are adding the click handler for the clear completed button. So you see this button here. If you click it, this code gets executed. Okay? So let's see how we can make it a bit nicer with Xtend. There are typical things like, well, one is you have to provide a val keyword. That's not making it simpler. But then you can use type inference, and which means in Java you have to provide a lot of type information explicitly all over the place. That's why so many people hate Java, especially from the dynamic language communities. They think it's the nature of statically typed languages to be that verbose. Scala proved that's not the case. Xtend does the same thing as Scala here. And then there are other things like you don't need semicolons, and you can do property access. So one important thing you need to understand with Xtend is that we looked carefully at existing Java items, like for instance Java Beans, and try to come up with first-class support in the language. So in that way, we mean Xtend is a better Java. It supports the existing Java items much nicer. What else? There is operator overloading, things like this. So you can do a lot of things, but this still is imperative Java-style code. And Xtend is a functional language, so you would instead write this. That is, filter me the to-dos, remove all the things which are done, and create a new list and assign it. Okay, using the same API we just saw, the setters and the getters and so, but much more readable. And also adding the handler is, you can do it like this. These square brackets is a lambda expression, and it calls the add-click handler, which expects a click handler, but these lambda expressions are automatically converted to an anonymous type of the target type. So in this case, a click handler. You can do this all over the place. Again, a very typical Java item, these kind of handlers and so on. So I think this has been improved a lot. But these kind of improvements you will see everywhere. This is not GWT specific. Let's have a look at these two things Ollie showed before. Just in case I'm a bit out of time, so that's why I'm so fast, right? I know I'm fast. So let's see how it is done in Java first. Ollie showed that already. You have to implement this class. And of course, you also have to implement the declare the interface and maintain everything. And also the async interface. That's how you do that in GWT. That's a boring task, very redundant. And in Xtend, we are going to introduce a new feature, which we call active annotations. And that allows us to do it like this. So that's how we did it in that application. You define in the library an annotation, and with that annotation, you explain what kind of modifications you want to do during the compilation. So you can participate in the compilation step from Xtend code to Java code. And you can do all kinds of things. You can generate new interfaces, as in this case. You can have errors and warnings, provide quick fixes. There are very, very many powerful ways to do that. And the very nice thing about it is that there's no special configuration needed. You just have to have it on the class path, and the compiler will pick it up, interpret the processing, and do the changes. So if you are in the project and you have specific annotations, then you can really, you have these super fast turnarounds. You change the annotation, you see all the other changing instantly. Okay? And then you just jar it and provide it, and other people can use it. So what this does is it adds just the needed boilerplate, generates an interface and these things, and the annotation we saw and those things. The other problem we saw is building UIs programmatically. So the traditional imperative Java style here. In Xtend, you can write it like this, because you can build a so-called builder API. So with the features, a combination of some features like the lambda expressions and so-called extension method, you're able to define an API which allows you to write UI or any kind of trees, could be JSON, HTML, XML, whatever, in this way. And you're in this statically typed world in your editor with all comfort you're used to.
And it's readable, I think. Just as readable as the XML, at least.
It's more readable.
At least.
And it contains the behavior as well. Well, this is really adding the on-click handling, right? Call, delete, to do there. You can do all kind of code there. But if you still want to use the XML, because there is a UI editor you want to use.
That's right, yeah.
So you have this XML, and you need to provide the handlers, right? You need to access the fields in order to add the handlers. Then in Java, you need to write this kind of code. So have a class next to the XML, have this magic on top here, which is some GWT compiler stuff. It doesn't make sense if you think of Java semantics, but it's GWT semantics more or less. And then you have redeclare all the fields. If you see, the information is already given here. It's a text box or a text box, and the name is to do text. And if you see here, there must be somewhere a text box to do text. So everything's there. So why not use an active annotation, which just looks into the XML, parses it, finds the fields, and declares them in your class automatically. So as soon as you add or change the XML, everything gets recompiled, and the fields are there or not there or renamed respectively. And the cool thing with these annotations is that you're really talking with the compiler, so the tooling is fully aware of your processing changes. That is, you have content assist to the fields and all these things you're used to. The scoping is exactly defined and so on. So I'm really looking forward to what kind of cool annotations we can create. I see many applications for this. We are good in time. I speed up too much.
Oh, that's okay.
The wrap-up is GWT is very cool, and especially the upcoming 2.5 version, because that one is going to be even closer to the browser API. So today you already have access to DOM and these stuff, but there are some more interesting HTML5 APIs which you can't access yet. So you can build these canvas demo I showed in the beginning, but there are some things you can't do. And in the future, you will be able to. And they also have a very cool new mode to be able to debug in the browser. If you have done some browser applications with JavaScript, you might know that there are very powerful tools these days. When I first started with JavaScript, it feels like in the 80s or so. But there was always no tooling and always the same message from Internet Explorer, no matter what problem was there. But a message was even good in case of JavaScript. So there's a lot of good future in GWT. There have a committee, a lot of interesting companies participate and contribute to the GWT. And we think with Xtend, it's even much more fun to write these GWT web applications. And not only fun, but you will be more productive with it.
And I have to add that those active annotations Sven is going to introduce, or has introduced actually, they are much more powerful than annotations than you know from Java, because once you have written those annotations there on top of your file, you are instantly able to access those fields that this annotation is creating for you. And this is something really special and cool stuff.
Yeah, there are many cool applications we foresee for these active annotations. So we have some time left for questions, just 2 minutes.
Yeah.
One thing I want to say is that the source code you will find on GitHub is based on the current head of Xtend, and it uses this prototype of these active annotations, and that will change a lot in the future. So this is really a bit of a preview.
Okay.
Is
Questions?
there a question? Yeah. No question.
It was so perfectly clear and convincing, so no questions. Okay, then?
There's one.
Oh.
A beta version, it's a plan to have the next release of Xtend around January. And it will include, for instance, a new formatter and overhaul type system, which speeds up the compiler a lot and the tooling. And it will have a beta version of this annotation processing. Beta means we have it is provisional API more or less, but fully workable. And a stable version is planned for summer. Yeah?
And the example you showed is where you generated the fields from the XML file. What happens if I change the XML file? Will it also trigger an recompilation of the associated class, or?
Okay, the question was, when I have this with binding annotation, which looks up the XML file and generates the fields, what happens if I change the XML? Does the compiler automatically know that there is a dependency to this XML? In all other cases where you use Xtend in Java, it will. In the case of some ordinary text file, it won't. But maybe we will find a solution to that.
Okay, I think time is over.
Okay, thank you very much.
Thanks a lot and have fun.